Hi, my name is Carl. I'm an astronomer, and oddly enough, I'm going to spend the next 3 minutes telling you about things we can't see with classical astronomy, the kind of things we actually can't see with a telescope, which is kind of a strange place for an astronomer to start, right? So far, optical astronomy and other forms of electromagnetic astronomy have served us pretty well, right? 400 years ago, Galileo came up with the first telescopes and discovered the moons around Jupiter, and up till the present day, we're seeing stars explode far across the universe. We're seeing planets around other stars for the first time. Hell, we're even seeing microwaves left over from the Big Bang itself, from the creation of reality itself. So why would I want to get up here and talk about the kind of stuff that we can't see? That's kind of a strange place for me to start. But, think about even the things we've heard about today, right? We've heard about dark matter, dark energy, black holes, things whose very names suggest that there's no way we'd ever be able to observationally see these things in the universe. How are we going to go out and see dark matter? How are we going to see a black hole? Now, there's a lot of different ways you can approach this. The one I particularly like, and the one I'm going to be talking about today, is the fact that we can create our own universes in a computer. We can actually take the physics we want. We can take what we want to understand, put it in a giant supercomputer, and start to understand stuff about the reality from our own invented universes. So some of us think on a smaller scale. They create solar systems, kind of like the ones we see around other stars, and they see what happens to those planets. Other people actually create entire universes in a box, and they watch what happens to that entire simulated universe over cosmic time. I do something a little more low scale than that. I look at these things called star clusters. They're basically big spherical blobs of stars just hanging out there in the universe that are held together by their own gravity. So anywhere from about 100,000 to a million stars just crunched down into a very small volume of space. Now, what do I mean when I say small volume? Well, that's what makes these things a little bit interesting. If you look at your typical galaxy, say something like this. It's about 100,000 light years in diameter. It takes light, the fastest thing in the universe, 100,000 years to go from one side to the other. And there's anywhere from 100 billion to a trillion stars in a typical galaxy. Now, in our local part of the galaxy, though, our nearest star is about 4 light years away. And so that's about 2 stars in that volume, covering about that entire distance. Now, in the same time, for one of these star clusters, imagine you took that same volume and you crammed about 200,000 stars into that same amount of space. The night sky would get about 100 times brighter. You wouldn't even need a flashlight in the middle of the night. And what makes these things really cool when you put them up on a computer, and what I look at, is how these things are born with anywhere from 100 to 1,000 black holes. So the clusters themselves, when they're born 12 billion years ago, actually start off with a huge number of black holes. And what we found by creating these computerized star clusters and looking at them is that the black holes are actually retained up until the present day. There are still anywhere from tens to hundreds of black holes just out in these star clusters floating in the center of these clusters in the galaxy. Think about it. It'd be like if there were somehow or another 10 to 100 black holes hidden between us and our nearest star, just hiding in the starlight near our galaxy. And so that's why I like to create various artificial things in a computer and see what happens over time.